Hey, how's it going everybody? Welcome back to my YouTube channel or welcome back on my YouTube channel. So I have been getting some requests to make a video about account takeover vulnerability. So I thought sure, why not? So in this video we are going to discuss everything about account takeover vulnerability and how it is carried out, what are some causes and preventions. If you are new to this channel, make sure to subscribe and hit the bell icon so you won't miss any cybersecurity and programming related content of this channel. Now before starting our topic, I would like to tell you that timestamps of all the topics I have covered in this video are in the description box below, so feel free to check them out. Now enough of chit chat, let's just get started. So what is account takeover vulnerability? But before understanding this whole thing, let's just understand about authentication and authorization. So what is authentication? Well, in simple words, authentication refers to the authenticity of someone or something that they claim to be. So in the web application or mobile applications, authentication is a process to determine whether something is really what it claims to be. For example, when we go to a website and try to sign in or log in, what web applications do is that they try to authenticate us with the information we provide. This information is usually a username and a password, but can be any other unique thing to identify a user. If this information matches with the information stored in the server, can be a database, the web application authenticates us and provide cookies for identification purposes. In case of a failed attempt, the authentication fails and we get an error in return. Now let's talk about authorization. So authorization comes after authentication. It means whether something or someone has privileges to perform a certain task. For example, an admin of a web application can view the list of users, their login history, upload files to web server, change the configuration and stuff like that. But a normal user is only authorized to access his or her login history or change his profile picture and stuff like that. So just for understanding, think of authorization as privileges a user or a certain object has to perform some task. An admin usually has the higher privileges amongst all the users. So now we are familiar with the differences between these two terms and what are they. Now let's just understand account takeover vulnerability and everything about it. So account takeover vulnerability is a kind of attack by exploiting which a threat actor can compromise an account of a user. Now this user can be a low privilege user or a high privilege level access user. An account of a user can be compromised in many ways. There are so many ways. It can be due to user stupidity or an actual loophole in the code of the web application, which we are going to discuss one by one. So the number one is using a common password and a brute force attack. Now using a common password can be a cause of compromising a user account. If a user uses a common password which can be guessed or brute force easily in a minimum number of times, then it may also lead to account takeover of that particular user. So we have a user Lily with password 123 as her password on a website. As you can understand, this is very common password and it's the user stupidity to use such a password. Another one is using the same password on every mobile or web application. Now, if an attacker has compromised Lily's account, let's say on example.com, then all of the other accounts on other websites Lily used the same password can be compromised very easily. Now, brute force attack, if the web server doesn't have any maximum number of failed login attempts, an attacker can simply create a list of passwords based on the user interest or most probable password user can use. For example, Lily here likes flowers and she is kind of obsessed with the flowers. Now the attacker can generate a list of passwords which contains names of flowers with some permutation and combination. Like Rose at 1234, Lily at 123, Lily at Lily, Sunflower at XYZ and so on. To prevent the user account from brute forcing, web server uses this feature to log the account from logging in even if the user passes a correct password after a certain amount of failed login attempts. Also, generating CAPTCHAs can be a prevention from a brute force attack. Let's say an attacker has a list of 2000 passwords and the correct password of the Lily's account is at 863 line. Now web server has this mechanism to lock the account after 50 failed login attempts in a row. Now only the first 50 attempts will be able to make the request, and after that web server will lock the login for the next 5 or 10 or even 30 minutes, or will give the forgot password option only. So it depends upon the behavior of a web server and how a developer chooses to implement restrictions. Now the above examples we discussed don't represent any flaws in authentication or in an application. Now let's discuss the actual flaws in an application due to which a user account can be compromised. First one, we have session hijacking. Now session hijacking is nothing but stealing session cookies of an individual user by exploiting cross-site scripting vulnerability. By the way, session cookies are a piece of unique data the web server provides after a successful authentication to identify a specific user. So a user won't have to log in again and again on accessing different web pages of the same web application. Let me give you an example. This can be done in two ways. First one is tricking a user to click on a malicious link, and the second one is injecting the JavaScript payload into the web page itself that will be executed whenever a user interacts with this web page. Now the above payload is a very common example of session hijacking by reflected cross-site scripting vulnerability. It's for just a basic idea. In the above payload, an attacker just redirecting our user with his or her session cookies to an attacker website with a store and cookie get parameter value. Also, this can be done using an asynchronous get post request that will execute the whole JavaScript code in the background and the user won't have any idea about it. Now the above payload can be injected in URL reflected XSS or can be injected into the web server stored cross-site scripting vulnerability. HTTP only flag in set cookie response header value is another prevention to access the session cookie by client-side scripting language like JavaScript. So if HTTP only flag is used, session hijacking won't be possible by exploiting cross-site scripting vulnerability. Session sitejacking. Now session sitejacking is a type of packet sniffing attack where an attacker sniffs the packet of an unencrypted communication on a network and intercepts the user session cookie. Later on, this intercepted session cookie can be used to compromise the user account. Website or web pages over TLS or SSL is a prevention of session clickjacking, as now the data will be encrypted, and even if an attacker manages to capture the network traffic, he/she won't be able to retrieve the session cookie as all the captured data will be gibberish without a key. Cross-site request forgery. Now cross-site request forgery is an attack where an attacker tricks the user to open a link through which an authenticated account can be compromised. How? Well, let me show you a basic example of how this attack works. Let's say we have a user Lily and we have an attacker named Bob. Bob wants to hack Lily's account on Lily website xyz.com. Lily is already authenticated on Lily website xyz.com and the session cookies is stored in her web browser. Now Bob sends Lily a link, can be a WhatsApp text or a mobile text or an email. Now it doesn't matter how the link is being sent. What matters is Lily is not enough suspicious not to open that link. Now Lily opens that link and she sees a genuine looking website. Since Lily is already authenticated on Lily website xyz.com, so in the background Bob has injected some malicious code which has been executed and led to compromisation of Lily account. But how? Lily only opened a link of a website that Bob has sent her. It was not the website she is currently logged in. So the code is simple. The malicious web page has a hidden form with predefined password values. Now since the Lily is already authenticated to Lily website xyz.com, the action will be carried out and will change Lily's password to password xyz without her acknowledgement. As soon as Lily clicked the malicious link the Bob has sent her, a post request will be made to Lily website xyz.com to change her password. Implementation of CSRF-Token is one of the prevention to save a user from this type of attack. CSRF-Token is just a hidden value that sends along with the form data, and then the web server validates it to check whether the request is sent from the genuine web page or not. In the above code, our post request parameters are like this without CSRF-Token. But if the web server has CSRF-Token mechanism implemented, then the above request parameters from a genuine web page will be something like this. Now, if the request is being carried out and the web server has CSRF-Token implementation, then in this case, the web server will refuse to change the Lily password, as now the request parameters has no CSRF-Token value in the parameters. Weak session cookies is another cause of account takeover vulnerability, As I have explained earlier, after a successful login attempt, web server provides session cookies that our web browser holds. This session cookie helps the web server to identify that a user is currently logged in. Let me give you an example of this. So let's say a web application has three types of users. First one is a student, the second one is teachers, and the third one is the administrator. Based on these, cookies is generated. Lily here is a student and she is currently logged in on this website. So here the cookie is something like this. Now just for the basic idea, what do you think which value can be a loophole? Let me tell you. Now we already know there are three types of users: the students, the teachers, and the administrator. Based on that, we can manipulate the label value to 2 and will save the cookie and can check that Lily now has a teacher level access privilege or not. Again, with the same logic, we can change this value to 3 or 0 or any other value. It depends on the web server. Now this cookie can be encoded in any format like it was in the above example. Again, it depends upon how the web server deals with this whole thing. Now there can be a loophole in the forgot password mechanism as well. For example, if a user clicks on forgot password, an OTP is generated. Now this OTP is 6 digits long and valid for the next 10 or 5 minutes. An attacker can also brute force the OTP by generating all 6 digits number. Again, to prevent this type of attack, a web server must regenerate the OTP after 5 or 10 failed OTP attempts or something like that. Other examples can be an information disclosure or a loophole in sending the OTP. If a web server has a loophole that let an attacker change the email or phone number to get the OTP code, then an account can also be compromised this way. For example, we have this web page and after clicking on forgot password, the user has to pass its username. Now after doing so, the web application retrieves the relevant details and let the user choose where he or she wants the OTP to be sent. If an attacker can manage to manipulate the email or phone number by making a request and the web server validates it, then an attacker can compromise any account by simply passing his email ID or phone number to get the confirmation or an OTP code. Now there are so many ways different web applications use this different mechanism and different loopholes can be there. It depends on how critical the vulnerability is and where it is present and what can be achieved by exploiting it. Passwords and username from data breaches can also lead to account compromisation. Using weak and same password can also lead to account takeover, disclosing of credentials, weak authentication mechanism, and any other flaw in authentication or session management within the web application can lead to account takeover vulnerability. Saving hashed values of user passwords and other confidential information in databases is another good measure to save users' critical information from being exposed if any data breach occurs. That's all for today's video. I hope it has been informative for you and you enjoyed it. Please like this video and subscribe to this channel. Take care. We'll meet you again in another video with cybersecurity or programming related content. Till then, goodbye.